Okay, so good morning to my lecturers. So this is my presentation for the assignment. So for the question one, we have to find the net force along the x-axis first, which we get to know is F1 is equal to 200 Newton and F2 is equal to 150. So along the f-axis, we will have 150 cos 60 plus 200 cos 45 degrees. So we will get the answer, which is 216.42. So for the net force along the y-axis, we use the formula, which is 150 cos 30 minus 200 cos 45. So we will get the answer, which is negative 0.52 for the net force along the y-axis. So how do we get the resultant force? So the resultant force, we will use the formula, which is R equal to square root net force along x-axis square plus the square of the net force along the y-axis. So we sub the net force along x-axis and net force along the y-axis, we will get the answer, which is 216.7. So how do we get the angle? So for the angle, we will use the theta, which is equal to the tangent Fy over Fx. So we will get a negative 3.047, which is the clockwise direction. Or if we want to use the positive value, we will use the counterclockwise. So for question two, we will have a P and the four forces with F1, F2, F3, and F4. So we will use the vector to calculate for the forces for F1. So for F2, we will, as we know the value, which is negative 120, and F4 will use the negative 300 for the value. So F3, we will use the Fx plus Fy plus Fz. So P cos 20 J plus P sin 20 K. So for the sum of Fx, we will use the value for the I, which is negative 44.313 plus Fs equal to 0. So Fs will equal to 44.313 kilonewton. For the Fy, we will use the I, and we will use the J. So for J, we will have F1 and F2. So F3, we don't know. So plus 0.9397p, which is the cos 20. So for Fz, same thing. We will repeat the same formula. We are using the value of K, which is 177.252 and negative 300K plus the F3 Fz that is unknown plus P sin 20K. So equal to 0. So from the equation 1, we will get to know that we will have a equation with P squared minus 892.459p plus 162.095 equal to 0. So by solving it, we will have two answers, which is P equal to 638.65 kilonewton. If we sub this value in, we will get the Fy, which is negative 169.95 kilonewton. So with P equal to 253.81 kilonewton, the Fy will be 191.69 kilonewton. So why do we use the P equal to 639 kilonewton? Because the y-axis is below the 0 degree. So below 0. So it is in the negative direction. So we use the P equal to 639 kilonewton. So F2, F3 we will get to know. And for F3, as we need the angle for F3, so we will use the cos to get all the degree. So for the degree, which actually is the FZ we get to know after we all substitute in, we will get to know the FZ is negative 95.672. So for the angle, we'll use for I, we use for alpha. For J, we use for beta, and for Z, we use for gamma. So for the alpha, for the I, we will get the SSC, which is 77.2 degree. For the beta, we will get 148 per degree, and for gamma, which is the Z-axis, we will get is 119. So for the question 3, we know that the value given from the question is with the force of 4 kilonewton and the moment of A is negative 10 kilonewton per meter. So moment about A, how do we get to find the moment about the A? So moment about the A, we will use the equation which is negative f sine theta times 3, as we get to know in the question is given the value of 3, and f cos theta 0.45. So as we know, the moment about A is negative 10, so we sub the negative 10 and all the value, the force, into the equation, and we get to know that it is negative 12 sine theta plus 1.8 cos theta plus 10 equal to 0. So how do we get the angle? Because we need to get the angle of this. So we will use cos square theta equal to 1 minus sine square theta. So we will use the 1.8 cos theta, we square it, and the 12 sine theta minus 10, we also have to square it. So after we square, we will get, and we use the 1 minus sine square theta to represent cos square theta. So we will get the answer, which is 147.24 times sine theta minus 0.8149 square minus 1.04 equal to 0. After we solve it, we will get the degree, which is 46.96 degree or 64.03 degree. So for question 4, we have a free diagram which consists of 6,000 and with the tension, the force, the length between the NA with the center mass, and the MB with the tension of 6,000 Newton. So for the sum of SZ equal to 0, if we know that we have only sum of Fx and sum of Fy. So sum of SZ equal to 0, and we will use 6,000 sine 60 minus F equal to 0. So we will get to know that the force is equal to 5,196 Newton, which is equal to what? 5.20 kilonewton. So for the sum of the center mass, we will use the center mass of gravity. We will use the NA times 4.5 plus the mg, and 6,000 sine 60 and 6,000 cos 60 equal to 0. So we will get NA is equal to 17.34 kilonewton. And the sum of the force equal, when the sum of force equal to 0, we will get to find the N for the B. So we will use 17.34 kilonewton minus the force, which is minus the mass times the gravity, and minus 6,000 cos 60, which is the angle here. So we will get the MB, which is 24.9 kilonewton. So for question 5, we will use the method which to find the joint one by one, which is from the joint A to joint F, then to joint E, to joint B, and lastly to joint C. So for joint A, we have a free diagram here, which is we have a force for F and force for AB with the degree of 45 degree. So sum of F, when sum of Fy equal to 0, so we'll use F force for AF sine 45 minus the P, as we get to find the P first. So for the force of AF, we will have 1.4142 P for the tension. So when sum of Fs equal to 0, we will use the same formula, which is, but we will get to know that the F force for AF is 1.4142 P. So we will use the equation into this equation. So 1.4142 P cos 45 minus force for AB. So we will find that force for AB is equal to PC, which is for the compression. So for the joint F, it will be using the same equation. So using the same diagram, just we have to change a bit, which we have to find F for the force for the FB and force for the FE. So when sum of Fy equal to 0, we get to find force of the for the FB. So it will be 1.4142 P for the compression. So when sum of Fs equal to 0, so we will find that A equal to 2 P for the tension. Same goes for joint E. So for joint E, it will be more easier. So since we know that F equal to Fe when the force at Fe is equal to 2P. So we get to find the F for ED and force for EB. So for joint E, force for ED is equal to 2P for the tension. So sum of Fy equal to 0. So since the sum of Fy equal to 0, so automatically the force for the EB is equal to 0. So next, we going to find the joint for B. So for the joint of B, we know that force for FB is equal to 1.4142 P, and with the angle of 45 degree for between force for AB and force for FB. So since F for EB equal to 0, so we can find that the F for BD and F for BC. So sum of Fy equal to 0, we get to find for the F force for BD, which is same answer, which is 1.4142 P for the tension. So when sum of Fs equal to 0, we substitute into the equation, so we will get to find that force for BC equal to 3PC. So lastly, for the joint C, we will get to know that saying that 3P equal to NC, so NC is equal to 3P. So since sum of Fy, when sum of Fy is equal to 0, so we get to find the sum of the CD. So sum of force for CD is equal to 0, as we don't have the value. So why we get to know NC is equal to 3P? So that is why we know that the F equal to BC is equal to 3P. So from the above, we get to know that the compressive and tensile force develop. So we get to know that the tension. So for the tension is equal to 4 kilonewton. So which is 2P. As we get to know for all above, from the joint A to joint F to joint E to joint B and lastly to joint C, we know that the tension is 2P equal to 4 kilonewtons. So what we get to know that the P is equal to 2 kilonewtons. So for the compression, for 3P equal to 3 kilonewtons, so we get to know that for the P for the compression is 1 kilonewton. So lastly, for the question 6. For question 6, it asks us to draw So for 0, we equal to x or less than x, but it's less than a. So Fy equal to 0, so V equal to P. So we are going to draw this equation as this. So since we know that the M equal to Px, so we will have a diagram which is P with A in between it. So for A to X but less than L minus A, we will have a diagram which is the L minus 2A is in the between and the A is from the side to side. So next we see for L minus A less than X but less than or equal to L. So since Fy equal to 0, so V equal to negative P. So for the P equal to negative, it will be the force from the bottom to the upper part. So for the B, we have said that the P equal to 4 kilonewton, for A is equal to 1.5 meter and L equal to 3.6 meter. So for the first one, we have to find that it's X is less than or equal to 0 but less than 1.5 meter. So we know that V if Fy equal to 0, so we get to know that V is equal to P, so it's equal to 4 kilonewton. So how do we get to know that? So how do we draw? So we will draw this by the 4 kilonewton is from the bottom to the upper part. So M is equal to 4x kilonewton per meter. So we will have this with 1.5 meter here. So for 1.5 meter, for the next question, which is x is less than 1.5 meter but less than 2.1 meter. So V equal to 0. So we will have the equation is like this. Not the equation, the diagram as follow. So for the last question is for the s equal to less than 2.1 meter but less or more than 3.6 m. So we will have the diagram which is actually same as the previous question, which is x less than 1.5 meter but less than also 2.1 meter. So we will have a positive and a negative side, as we know that we have a negative 4x plus 4x. So we will have this type of diagram which is to differentiate which part is for the positive and which part is for the negative. So for the last one, since it is equal to 6, we have a 6 here, 6 kilonewton. So we have a parallelogram, which is the diagram for the 6 kilonewton per meter. So that's all for my presentation. Thank you.